Two of the most powerful telescopes ever built just pointed at the same tiny object moving through our solar system, and they came back with matching answers that nobody expected. The object is called 3I Atlas, and if that name sounds unfamiliar, here's why it matters. It is only the third interstellar object ever confirmed passing through our solar system, following Oumuamua in 2017 and Borisov in 2019. Unlike those two, this one has now been studied by both the James Webb Space Telescope and the brand new Vera C Rubin Observatory, and their results line up in a way that has scientists paying very close attention. Let's start with what this object actually is, because the basics matter before the strange part makes sense. 3I Atlas was officially discovered on July 1st, 2025, by a network of ground-based telescopes designed to spot exactly this kind of fast-moving intruder. What made it stand out immediately was its orbit. Instead of looping around the sun the way planets and ordinary comets do, it was tracing a hyperbolic path, meaning it came from somewhere outside our solar system entirely, swung past the sun, and is now heading back out into interstellar space, never to return. That alone makes it one of the rarest objects astronomers ever get to study up close. Every other comet we've ever examined in detail formed here, inside our own solar system, orbiting the same sun as Earth for billions of years. This one didn't. It formed around a different star, in a different part of the galaxy, long before it ever crossed paths with us. To put its rarity in perspective, humanity has now confirmed exactly 3 interstellar visitors. The first, Oumuamua, was spotted in 2017, and it was so strange, looking elongated and tumbling with no visible tail, that scientists barely had time to gather data before it sped away. The second, Borisov, arrived in 2019 and behaved much more like a familiar comet, giving astronomers their first real close look at interstellar material. 3I Atlas is the third, and by far the most extensively studied of the 3, largely because modern telescopes, including 2 brand new ones, happened to be ready and pointed at the sky exactly when it arrived. Once astronomers realized what they were looking at, the race began to point every major instrument available at it before it disappeared again. That's where James Webb comes in. In early August, Webb used its NIR spec instrument to capture detailed infrared readings of the gas cloud called a coma surrounding the comet's nucleus, and what it found immediately stood out. The coma was overwhelmingly dominated by carbon dioxide, with the ratio of carbon dioxide to water among the highest ever measured in any comet observed by humanity. Water, ice, carbon monoxide, and even a faint trace of a sulfur compound were present too, but carbon dioxide was doing almost all of the outgassing. For context, most comets from our own solar system release far more water vapor relative to carbon dioxide when they heat up near the sun. This one was doing almost the opposite. That single detail told scientists something important. The conditions where 3I Atlas originally formed were different enough from our own solar system that its basic chemistry came out looking unlike almost anything native to our cosmic neighborhood. Researchers pointed out that this kind of carbon dioxide-rich composition could suggest the comet formed farther from its parent star, in a colder region where carbon dioxide freezes more readily than water, or that it spent much of its long existence exposed to far more cosmic radiation than anything in our own solar system ever experiences. Webb didn't stop there. Follow-up observations taken later, after the comet had already swung past the sun, detected methane appearing in its coma as well, and its arrival was delayed in a way that suggested it had been buried, deep inside the object, only reaching the surface once solar heating finally worked its way down through the comet's layers. Scientists also noted that the amount of methane relative to water was unusually high, another chemical marker that doesn't quite match anything typically seen in solar system comets. Every new reading kept reinforcing the same conclusion. This thing formed somewhere fundamentally different from anywhere in our solar system. Now here's where the Vera Rubin Observatory enters the story, and where things get genuinely surprising. Rubin is a brand new ground-based telescope in Chile, equipped with the largest digital camera ever built for astronomy, capable of photographing the entire southern sky in enormous detail every few nights. It had only just begun its science validation phase, essentially a testing period before full operations, when 3I Atlas was discovered elsewhere. Researchers went back through Rubin's early test images, taken before the observatory, was even fully operational, and found something remarkable. The telescope had actually captured 3I Atlas more than a week before it was officially discovered by anyone else, sitting quietly in test data that nobody had reason to examine yet, because at the time, nobody knew there was anything unusual in the frame at all. Once astronomers pulled those early frames and properly analyzed them, they didn't just confirm the object's existence earlier than expected. They measured its composition independently, using a completely different method than Webb's infrared spectroscopy. Rubin relies on optical imaging rather than infrared spectral analysis, meaning it's essentially looking at the object through a different kind of lens entirely. and the carbon abundance Rubin detected matched what Webb had already found. Two entirely different telescopes, using two entirely different techniques, arriving at the same conclusion about the same object's unusual carbon-rich chemistry. That kind of independent agreement is exactly what makes scientists confident a result is real, rather than some instrument quirk or observational fluke. When Webb's infrared spectrograph and Rubin's optical imaging both point to the same unusual chemical signature, the odds that it's a coincidence or an error drop dramatically. So why does any of this matter beyond a neat coincidence between two telescopes? Because 3I Atlas isn't just chemically strange. Some researchers studying its light curve and structure believe it may be extraordinarily old, potentially forming somewhere between 10 and 12 billion years ago, in a distant part of the early Milky Way. If that estimate holds up, this object would be more than twice the age of our entire solar system, and not far off the age of the galaxy itself. That would make it quite possibly the oldest comet ever directly observed by humanity. A genuine relic from an era of the galaxy that existed long before our sun ignited, drifting through interstellar space for billions of years before randomly crossing paths with a planet capable of pointing telescopes at it. Think about what that actually means for a moment. This object has been traveling silently through the emptiness between stars since roughly the time the very first generations of stars in our galaxy were still forming. It has outlasted entire stellar life cycles, drifted past countless star systems, and simply kept moving, completely unaffected by anything happening within any of them until it happened to pass close enough to our sun for its ices to start warming and releasing gas, turning what would otherwise be an invisible chunk of ancient rock and ice into something bright enough for us to actually detect and study. And yes, given how unusual and unfamiliar all of this sounded, it didn't take long for online speculation to spiral toward more dramatic explanations, including suggestions that an object behaving this strangely might not be a natural comet at all. Some of that speculation even came from credentialed researchers willing to entertain the idea publicly, which only fueled more attention online. It's worth being straightforward here. The overwhelming consensus among the astronomers actually studying the data at Webb, at Rubin, and everywhere else pointing instruments at this object is that 3I Atlas is behaving exactly like a comet. It has a coma. It's releasing gas as it warms near the sun. Its brightness and activity change in ways consistent with sunlight driving ice sublimation. And its chemistry, while unusual, fits within the physics of how comets form and evolve. Unusual is not the same thing as artificial, and every serious dataset gathered so far points toward a natural, if genuinely ancient and unfamiliar, interstellar comet. What makes the real story exciting isn't some conspiracy angle. It's that we are, for the first time, getting a detailed chemical fingerprint of material that formed around a completely different star system, long before our own sun existed. That's an almost unbelievable scientific opportunity, and it's the reason so many telescopes scrambled to study this thing while they still had the chance, squeezing in observations from Hubble, ground-based observatories like Gemini, and specialized infrared missions like Cepheirex, all racing against the clock before the comet became too faint and too distant to study in any meaningful detail. There's also a bigger picture worth appreciating here, and it goes beyond just this one comet. Rubin Observatory only just began its full 10-year survey of the sky in the summer of 2026, scanning the entire visible night sky every few nights, and generating more data in its first year alone than every other telescope on Earth combined. Its software is designed to automatically flag anything that changes or moves between successive images, potentially sending out millions of alerts about new or unusual objects. Scientists studying 3I Atlas believe that Rubin's constant, continuous coverage of the sky means it's likely to catch far more interstellar visitors like this one in the years ahead, possibly dozens of them, rather, than the rare handful we've spotted so far using older, far less comprehensive survey methods. That changes the entire calculation. Instead of getting lucky once every several years when an interstellar object happens to be spotted crossing our solar system, astronomers may soon be able to study a genuine, growing catalog of visitors from other star systems on a regular basis. Each one would carry its own chemical fingerprint, its own clues about the conditions and the star system it formed around, gradually building an entirely new field of comparative interstellar chemistry that simply didn't exist a few years ago. And that's really the heart of why this particular story matters so much. It's not just two telescopes confirming one strange object. It's a preview of an entirely new era in astronomy, one where, instead of only studying material that formed in our own solar system, scientists can directly sample chemistry from other corners of the galaxy, brought right to our doorstep by objects that have been drifting through interstellar space for billions of years. Every new interstellar visitor Rubin catches in the coming years will add another data point to that picture, slowly turning what used to be an incredibly rare event into an entire new branch of comparative astronomy. 3I Atlas is already on its way back out of our solar system, and within a relatively short window it will be gone for good, drifting back into the depths of interstellar space where it came from, never to pass this way again. But the data Webb and Rubin gathered during its brief visit will keep researchers busy for years, feeding into models of how comets form around other stars, how radiation and cold shape the ices that end up locked inside them, and how galaxies as a whole recycle material across billions of years. It has already reshaped how seriously scientists are taking the search for the next one, and observatories around the world are now actively refining their strategies specifically so they're ready the moment the next interstellar visitor gets spotted. If you find this kind of discovery as fascinating as I do, hit that subscribe button, because with Rubin now scanning the entire sky every few nights, this almost certainly won't be the last interstellar visitor we get to. Study up close, and I'll be covering every one of them as the data comes in.